Let's look at the 16th proposition of book 3 of Euclid's Elements. We are given a circle, right? And we know how to find the center of the circle. We know how to draw a diameter. Let's pick a random point on the circumference. Let's draw a line through D and B. Mark the intersection point on the other end, and AB would be the diameter. So the proposition says a line perpendicular to AB, that is one end of the diameter, lies outside the circle. The second part of the, okay, let's draw the perpendicular as well to AB. So the proposition says that this line EA falls outside the circle. Second part says that you can't have a rectilinear angle between EA and this circle. In between, you can't have. And the third part of it says that this angle BA and this curve, the angle formed between AB and this curve, is always greater than any acute rectilinear angle. And the angle between the circular curve and AE would always be less than any acute rectilinear angle. So let's prove each one of these parts one by one. So let us take a point C, right? It makes more sense to keep it as close to A as possible, but because of clarity purpose, I'm keeping it here. Now we are going to join AC, join CD. Now remember, here our assumption is what? That the line CA is perpendicular to AB. That means angle DAC is equal to 90 degrees. AD is equal to CD in this triangle. Why? Because they are both radii of the same circle. And we know that angles opposite to equal sides are equal. So that means DAC is equal to DCA. Within a triangle, you can't have two angles as right angles. So that means this is an impossible situation. So that shows that a line, a tangent line, does not fall inside the circle. Okay, let's hide this now. Now the second part says that we cannot have a rectilinear angle between BAE and the angle formed by BA and this curve, what is also called as a curvilinear angle. Again, proof by contradiction. Let's assume that there is a such line. Let's have an F and let's draw a line. We can keep it as close to it as possible, but because of the points that I require here, it will become very difficult to read. So let's keep it here. Now we are going to join, or rather draw a perpendicular to AF from D, and we will mark the intersection of the circle with this perpendicular line as H, and we will mark the intersection of this perpendicular with AF as G. Now remember, here it can't lie inside the circle, right? So what we are saying is that this line AF is between these two. That means GD is greater than DH. That is how it should be, right? It should be outside. But AGD is right angle and DAG is an acute angle. That means AGD is greater than DAG. That means the side opposite to AGD is greater. That means AD is greater than GD. But AD is equal to DH, radii of the same circle. So which means what? DH is greater than GD, which can't be correct. Why? Because GD is supposed to be greater than DH, because it can't lie inside the circle, because it is, for explanation purposes we have drawn this like this, because we really cannot, the proposition itself says we can't draw it, so we are assuming this. So you have to remember that GD is greater than DH, because this line is supposed to fall outside the circle. That means G is supposed to be outside the circle. That means GD is supposed to be greater than DH. But just now we saw that AD is greater than GD, and since HD and AD are the radii of the same circle, we end up with HD is greater than GD, which is not the case. Don't look, just look at this figure. Remember, G is supposed to be outside the circle. So we can say that we cannot have a line between EA and, let's say, the curve HA. Now let's look at the last part of the proposition, which says that the curvilinear angle BAH is greater than any acute rectilinear angle, and the curvilinear angle HAE is less than any acute rectilinear angle. So basically here, just try to visualize this and see whether we can have a bigger angle than BAH, which is acute and is rectilinear, and another angle which is smaller than the curvilinear angle HAE. That means if we can come out with that situation, then there would be a gap, and we would be in a position to draw a line. But just now we proved that that is not possible. We cannot draw another line here. We use this line as an example. So since we have proved that such a line cannot exist, BAH curvilinear angle will be greater than any acute rectilinear angle, and HAE would be less than any acute rectilinear angle. So that was proposition 16 of book 3 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions. Please feel free to download it, refer to it, and share it if you feel somebody else can benefit from it. That's it for now. Bye.